Bell work for today is figuring out which of the following relations represents a function. Remember, for it to be a function, there can only be exactly one output for each input. So A would not be a function because C goes to two different numbers, so A is no. B, you do not see the same x value twice, so that one's fine. B is a function. C, the easiest way to look at a graph and know is if it passes the vertical line test. Since this passes the vertical line test, yes, C is a function. I'll come back to D in a moment. On E, this would not pass the vertical line test. Right there, it crosses twice, so this one would be no, not a function. Now D, this is in the form y equals mx plus b, which makes it a linear equation. And any linear equation is a nice diagonal line like that, which would pass the vertical line test. So D is yes, it is a function. So if this was something on the EOC where it says select all that apply, you would select B, C, and D. As a bit of review, graphing each of these using transformations, giving the vertex and the intercepts. The first one's a quadratic, which means it's going to look like a parabola, specifically one that's been shifted up 2. So we'll start at 2. Since it's a parabola, it's got that nice pattern to it where you go up 1, and then up 3, and then up 5. This graph does not cross the x-axis, so there are no x-intercepts. It crosses the y-axis at 0, 2, so that's the y-intercept. And the vertex, or the minimum on this one, would be 0, 2 as well. The second one is an absolute value equation. It has two transformations. One is that it's going to the left 4, and the other one is that it reflects across the x-axis. Absolute value means it's going to be a V shape. So to the left 4 and then opening down. This one does have an x-intercept, only one. It's happening at -4, 0. It has a y-intercept happening at 0, -4, and this one has a vertex, a highest point, or a maximum at -4, 0. Looking at the graphs, you have to be able to look at a graph and tell me what type of a function it is. That first one is a parabola, and every parabola is a quadratic. Number 4 is a V shape, which means it's absolute value. This flat horizontal line is what we call constant. This nice diagonal line at number 5 is linear. On number 6, that slide-looking thing, that's exponential, specifically exponential decay.
The internet is experiencing some problems, so if you have trouble, we are aware of it, and our tech people are on it. Thank you.
All right, and then number 3, what's left is that cubic. In order for something to be a linear equation, it has to look like y equals mx plus b. It has to have x to the first power. In order for it to be quadratic, it has to have an x squared in it. And in order for it to be cubic, it has to be x to the third. For it to be exponential, the x has to be in the exponent, so something like 2 to the x. Absolute value, it has to have the absolute value bar, so, absolute value of x. For it to be constant, that's a horizontal line, so like y equals 5. All right, what we're talking about today is if you're given a table of values rather than a graph and explaining what type of function it is. You can always plot the points and look at the graph to determine which graph it looks like, but if you're just looking at a table, you can also look for a pattern. So to get from -2 to 0, you add 2. From 0 to 2, you add 2. To get from 2 to 4, you add 2. To get to 4 to 6, you add 2. Since this number is the same, the first time around, it is considered a linear function. On the next table, if you look for the pattern, +1, +3, +5, +7. Okay, that number is not the same at that point, so you do it again. You add 2, add 2, add 2. That time it's the same. So the second time around, you got the same number, which makes it a quadratic function. On this one, you would have to add 1, add 7, add, whatever 25 minus 6 is, 19, and then add, I want to say 37, but I'm not sure. Hold on. 12 minus 5 is 7. Yep, 37. Clearly not the same number, so we do it again. That would be plus 6 plus 12 plus 18. Still not the same, so one more time. Plus 6 plus 6. It happened 1, 2, 3, so the third time out, we got the same number. So if you have to do it 3 times, that means you're dealing with a cubic function. Oops, too far. Now in this one, adding and subtracting isn't going to get you what you need to do. The pattern in this one is multiplication. Specifically, you're multiplying each time by 3. Even 1/3 times 3 gives you 1. 1 times 3 gives you 3. 3 times 3 gives you 9. 9 times 3 is 27. So each time you're multiplying by 3. So anytime you're multiplying, it's going to be an exponential function. All right, so looking at a couple of examples. If you start off for a pattern, that would be plus 7, plus 1, plus 1, plus 7. All right, not the same number, so we do it again. To get from 7 to 1, you actually have to subtract 6, so we'll say minus 6. To get from 1 to 1, you're not going anything, so we'll say plus 0. And then to get from 1 to 7, you have to add 6. Second time around, not the same number, so do it one more time. To get from negative 6 to 0, you add 6. To get from 0 to 6, you add 6. Took us 1, 2, 3 times out, so this is a cubic function. Let's see, I'm actually going to scroll down to this one. This is on the back of that paper I gave you. And your pattern here is that you are dividing by 2. Okay. 80 divided by 2 is 40. 40 divided by 2 is 20. 20 divided by 2 is 10. 10 divided by 2 is 5. So we didn't talk about what happens if you're dividing, but the nice thing about division is that it can always be rewritten as multiplication. Dividing by 2 is the same thing as multiplying by 1/2. So times 1/2, times 1/2, times 1/2, times 1/2. And since it's multiplication, that means it is an exponential function. All right, now on your homework for tonight, on all of the equations or table of values that you're looking at, you just have to tell me what type of function it is. You don't have to write the equation for it because that's what we're going to do in class on Wednesday. So make sure you have all of them identified for tomorrow.